Trickling filters are biological reactors within wastewater treatment plants, which are used to remove organic matter and/or ammonia from wastewater. Compared to the activated sludge process, the microorganisms are not suspended in the mixed liquor, but they are attached to a fixed bed surface. Nowadays, the fixed bed surface is usually provided by structured plastic fill media, but in the past, rock, gravel, and hardwood was also used. Wastewater from primary clarifiers is continuously trickled over the first layer of plastic fill media using a rotary distributor. While wastewater is traveling down to the bottom of the trickling filter, a cross-corrugated pattern within the plastic fill media ensures a good water-air mixing. Trickling filters are operating under aerobic conditions, but mostly without the use of forced ventilation or aeration. Instead, the tower shape of trickling filters causes that air is sucked inside the tower over slots at the trickling filter bottom. This effect is also called chimney effect and results from air buoyancy, which occurs due to a difference in indoor to outdoor air density, resulting from temperature and moisture differences. For the design of trickling filters, three components are very important: the support structure, plastic fill media layers, and the rotary distributor. The support structure has to withstand high vertical loadings of up to 50 kilograms per cubic meter, 3 pounds per cubic feet of plastic fill media, plus up to 250 kilograms per cubic meter, 15 pounds per cubic foot for attached sludge and water inside the fill media packs. At the same time, the supporting structure must leave enough space for sludge collection and removal and to avoid blockage of plastic fill media channels. Therefore, the support structure typically consists of PVC stanchions, FRP grating, and slope corrector plates to adjust for bottom slopes. The plastic fill media layers must provide enough surface area for attached growth of microorganisms, ensure a good water and air mixing, as well as withstand structural loadings. Typical removal rates for trickling filters are between 5 and 20 grams BOD per square meter plastic fill media surface area per day and 1 to 2 grams ammonia per square meter per day. Plastic fill media is available in different types with various specific surface areas. As higher the surface area, as more microorganisms are available and as better is the performance of the trickling filter, but at the same time as higher is the risk of clogging. During the lifetime of a trickling filter, the plastic fill media will be exposed to many different outer impacts, such as water, UV radiation, changing load requirements, foot traffic, and cleaning procedures. In the beginning, these effects will be barely noticeable, but over time, especially the bottom and top layer of plastic fill media start to deteriorate. With increasing damages, the air and water distribution within the trickling filter gets worse and worse, so that the performance of the trickling filter starts to decrease. When the bottom layer compresses and the top layer shows cracks and broken channels, it's time to exchange the plastic fill media. To maximize the lifetime of plastic fill media, the layer distribution must be properly designed. The material thickness of plastic fill media foils can be varied depending on the structural loading requirements. Therefore, for a long time, 30 years, the bottom layer should be reinforced, followed by average to low material thickness fill media layers, and finished with a high material thickness, reinforced top layer. Finally, the purpose of a rotary distributor is of course a good water distribution, so it's also used for plastic fill media flushing. For an even spray pattern, a certain distance between top of plastic fill media and rotary arms must be determined. As the spray area enlarges with increasing distance from the central shaft, more spray nozzles have to be placed at the end of the rotary arms, compared to the beginning of the rotary arms. Finally, the amount of water trickled above a certain plastic fill media area per minute influences the flushing effect, also known as Spoolcraft or SK value. As higher the SK value, as thinner is the layer of microorganisms attached to the plastic fill media surface. The goal is to maintain enough microorganisms for BOD and ammonia removal, but to prevent excessive microorganism growth and clogging of fill media channels. Thanks for watching, and if you like our 3-minute tutorials, please subscribe and don't forget to give a thumbs up.